This is section 5.2, verifying trig identities, trigonometric identities. Now, section 5.2 and 5.3 coming up do have a little bit of overlap, a little bit of similarity, where 5.2 is verifying trig identities, whereas 5.3 is solving trig equations. Now, the goal of 5.2 is to study the specific techniques that we're going to use to verify these trig identities, because these techniques are going to be useful when we come around to do 5.3, where we're going to be solving trig equations using the trig identities that we've been able to verify and manipulate, and a little bit of algebra to actually solve the trig equations. Now, when we think about equations, there's generally two different types of equations we can consider. Either we have conditional equations, or we can have identities. Now, in reality, we're going to be looking at both of these different types of equations. Conditional equations are the ones that you would end up having to solve for a particular value, whereas identities would be the ones that you would have to prove are identities, for lack of a better word. But one example we can kind of talk about here to get a better sense of what the difference is between these two is to look at one of the simplest conditional equations that you're going to encounter in trig concepts. And that is the equation sine x equals 0. Now, this looks like your typical equation where one side of the equal sign is equal to something else on the other side of the equal sign, but this is a conditional statement because sine of x is equal to 0 only when x is some multiple of pi. So this is only true when x is equal to pi or 2 pi or 3 pi or 4 pi or any continuous multiple of pi from here on out. So when we talk about this sort of a situation, we're basically looking at this equation and starting off with that. But if you wanted to solve it for x, you would have to go ahead and take the inverse sine of both sides. So this is how we would actually approach solving this equation. So now that we have a little bit of an idea of how these inverse trig functions work, this part of that equation here would basically be telling you to think about an angle value whose sine is 0. And that's what brings us back to the whole idea that x is only equal to some multiple of pi where sine of that value, sine of that angle would be 0. So this is what we call a conditional equation, this first one that we started off with. So sine of x equals 0 is an example of a conditional statement. Identities, on the other hand, would be equations, once again, but the interesting thing about how identities work is that you have an equation that says something like this, where sine squared x is equal to 1 minus cosine squared x. Now, this is an example of an identity because this statement is true for all x values. So if this is going to be true for all x values, then we can consider this an identity as a result of that statement. And we're basically going to be dealing with equations that look like this in the section that we're focusing on today.